start the manufacturing process. Art Science Commerce College Chikaldara, Department of Industrial Chemistry, BSc third year. Manufacturing of ammonia from the nitrogen and hydrogen. Now we see the manufacturing of ammonia from nitrogen and hydrogen. The Haber process. In the Haber process, combine the nitrogen from the air with the hydrogen derived mainly from the natural gas as a methane into ammonia. That is a raw material required for the manufacturing of the ammonia. Nitrogen is recovered as the cheapest source of the nitrogen is the air, and that hydrogen is recovered from the cracking of the methane from the natural gas that we utilize for the manufacturing of the ammonia. The reaction is the reversible, and production of the ammonia as an exothermic reaction, that heat is generated within that process. But this nitrogen and hydrogen is combined, and a normal condition that not give the proper yield. That's why we carried out processing in presence of the catalyst. Now we see the flow chart for that manufacturing of the ammonia. Now nitrogen from the air within that first block. Now hydrogen is from the natural gas, that is cracking from the methane. Methane is cracking into the form of the carbon and hydrogen. Only hydrogen is combined with the nitrogen. That nitrogen and hydrogen, we take the ratio is the 1:3 by volume. Now take within that catalytical reactor, that to maintain the temperature 400 to 450 degrees centigrade temperature and 200 atmospheric pressure in presence of the ion catalyst. Now this nitrogen and hydrogen is combined to form the ammonia. That ammonia is absorbed within that water, within that absorption tower, and get the gaseous ammonia is absorbed within that water, that to form the liquid ammonia. That is nothing but the ammonium hydroxide. That also we utilize that ammonium hydroxide as the one of the reactant as the ammonia. Otherwise we utilize the gaseous ammonia is utilized from the any application, that to manufacturing raw material is the ammonia. Now we see the again unreacted nitrogen and hydrogen is recycled to the catalytical reactor. Within that with the fresh material, that two ratio is maintained in the form of the mixed feed, that to unreacted form of the nitrogen and hydrogen, and we carried out the fresh feed of the nitrogen hydrogen to feed catalytical reactor. Now we see the actually, and this process is carried out in this way. The production of the ammonia from the natural gas is conducted by the reacting methane, that is natural gas, with the steam and air, that coupled with the subsequent removal of the water and carbon dioxide from the natural gas. The product of this process are hydrogen and nitrogen, which are feedstock for the main ammonium synthesis. During the process, the removal of the sulfur and other impurities is important, because they can reduce and damage the performance of the catalyst during the synthesis. In the ammonia synthesis process, both nitrogen and hydrogen are compressed to relatively high pressure to be fed to the synthesis reactor, where the catalyst is immersed inside the produced ammonia together with unreacted hydrogen, argon and other impurities, is then cooled down from ammonia condensation in order to separate the ammonia from the other gases. The unreacted hydrogen and nitrogen are then recycled back and mixed together with the new feedstock to avoid the buildup of impurities such as the argon. A small part of the gases is purged from the process. A ammonia synthesis produces a small amount of heat which is released from the reactor, that is the exothermic reaction. Therefore it can be recovered and utilized for the other process such as the steam and power generation. In the general, about the 88% of the hydrogen calorific value can be conserved. Now we utilize the some catalyst parameters is maintained within that manufacturing of the nitric acid ammonia. The catalyst is actually slightly more complicated than pure iron. That's why it has potassium hydroxide added to it as a promoter, a substance that increases its efficiency. And to maintain the pressure varies from the one manufacturing plant to the another, but always high. You cannot go wrong in an examination coating that 200 atmospheric pressure is maintained, that is better for the performance of the process. Now we see the recycling. At the each pass of the gases through the reactor, only about the 50% of the nitrogen and hydrogen converted to the ammonia. This figure also varies from the plant to plant. By the continuous recycling of the unreacted nitrogen and hydrogen, the overall conversion is about the 98%.